figure gives the xt plot of the particle in one-dimensional motion. 3 different equal intervals of time are shown. In which interval is the average speed the greatest? And in which it is the least? Give the sign of average velocity for each interval. So the question is simple. You have an xt plot, you have a position time graph, and you have 3 segments. 3 segments have been chosen on the graph, segment 1, segment 2 and segment 3. And you need to identify where is the average speed greatest and where is it least. And also, you also have to identify the signs of average velocity in all these 3 segments. And now to do so, we will have to certainly graduate the scale. Before that, we need to know what is the definition of average velocity. So we know average velocity, which can also be denoted by V average, is simply the change in displacement to time, which is nothing but x2, the change in the values of x to the change in values of time. So in each case, if you calculate and see which wherever the value is greatest, there the average speed will be greatest. Similarly, you can even when you graduate the scale, you can even find out the sign of velocity. So you see that this is in first quadrant and this is in the fourth quadrant, where the fourth quadrant will have a negative value of x here, this on the y-axis. So it's easy to calculate. So let's begin. Let's start graduating. Now let me call this as 1 second, 2, 3, 4, 5 seconds, 6 seconds, 7 seconds. I write this above, 8 seconds, 9 seconds, 10, 11, 12. Similarly, I graduate here, 1 second, 2 second, 3 second, 4, 5, 6 and 7. Similarly, this will be -1, -2, -3, -4, -5 and -6. So now it will be easy for you to calculate the average velocity. You will just have to find out the value of x1 corresponding to the time t1, value of x2 corresponding to the time t2. So this is t1 and this is t2 in the first case. So corresponding value of t1 is 2, t2 is, let's say, 2.4, or you can just call it as 2.5. So in the first case, the average velocity is simply here. In the denominator you have 2 minus 1, which is the time. In the numerator you have 2.5 minus 2. So this is 0.5 divided by 1, so 0.5 meter per second. Similarly, in the second case, this is t1 and this is t2, right? 5 and 6. So the values of x are the same in this case. There's hardly any difference, right? So I can call this V average in the second case is 6 minus 5, which is this value of time, whole divided, in the numerator you have, it's almost 6.2 minus 6, which is just 0.2 meter per second. Now in the third case, this becomes t1 and this becomes t2. So their corresponding values will be so this is a bit more than 6, right? So you have the third one, V average. Now the denominator is simple, 8 minus 9, 9 minus 8. But the values that correspond here are, this is 7, minus 7, minus of, minus, because you have got, you're subtracting and you have a minus value, minus 4.5. So that becomes so that will be minus 7 plus 4.5 divided by 1, right? It's nothing but, now if you just divide this, it's minus 7.0 and 4.5, so you have 5. This gets reduced to 2, so you get 2.5. So the answer is 2.5, yeah, with the minus sign, remember, minus 2.5 meter per second. So that tells you that there is a change in direction of the particle. So the negative sign just indicates that there is a change in direction of the motion of the particle. Now let's come to the question. Here we have to find out which has got the greatest average speed. So the greatest average speed, when you just look at the magnitude, this is 0.5, this is 0.2, and this is minus 2.5. So when you just look at the magnitude, you see this is the greatest. So the average speed is greatest in this case, segment 3. So you can just write that down in sentence. B average is greatest in 3, right? And where is it least? 0.2 is the least, which is the second graph. So V average is actually least in 2 in the second one. So third one is the greatest, least one is the second one. Now what are the signs? Now when you segment 3, V average has got a negative sign. Segment 2 and segment 1, the average velocities have got a positive sign. So this is how you solve the problem.